second verify question, sine squared theta times secant squared theta equals tan squared theta. Again, I'm going to start with the same box so that I have something to look at, and I'm going to draw the line down the equal sign. My goal is to pick one side and work only on that one side. I'm going to work on the left side because there's more to it again. Um, so the first thing I notice is everything is squared. And you might go straight to these Pythagoreans, but I'm not going to jump right there yet because what I notice is there's no addition or subtraction. And I would like to not introduce an addition or subtraction if I don't have to. Addition subtraction typically makes simplifying questions a lot more difficult. So I'm going to avoid that if I can. Since I'm moving away from the Pythagorean identities, I'm instead going to look at some of these reciprocal and quotient identities and remember that they can also be squared. So I'm going to use the same strategy that we used in example 1, which is to turn everything into sine and cosine. Again, I'm going to work with the left-hand side because it's a little bit more complicated. So I'm looking at this secant squared, and I want to try to get rid of that. So I'm going to look for secant over here in my reciprocal and my quotient identities. And I see it right here. Secant theta is equal to 1 over cosine theta. Now, I'm using the top one and not the one below it because the secant is in the numerator. The one on the one right below the highlighted one, it has a secant in the denominator, so it's not the one I want to use quite yet. So sine theta is going to stay, sine squared theta. And where there's a secant, I'm going to change it into 1 over cosine squared. So the only difference with the squared reciprocals is that it's squared uh, and not a single. So now that I have sine squared theta times 1 over cosine squared theta, I'm going to put these two things together. So just multiplying two fractions, and we get sine squared theta over cosine squared theta. Now that isn't anywhere in my box, but hopefully you can think of this from our time with exponents, and you would agree that sine squared theta over cosine squared theta, that's the same thing as sine over cosine squared. And sine over cosine is in my chart over here. Sine over cosine is tangent. So I can take sine over cosine out, and in its place, I can put a tangent. So I'm trying to highlight the pieces that are the same so that it's easier for you to follow. Now, tan squared or tan theta squared, that's the same thing as me saying tan squared with the square on the n, which is what we have here on the right side. Once you turn one side into the exact same thing as the other side, the question is done. Example number 3, we want to verify that sine x plus cosine x squared will equal 1 plus 2 sine x cosine x. I've got my box of identities next to me so that it's easy to work from. I'm going to draw the line down the equal sign, and I'm not going to cross it, so I can't add to both sides. So I have to decide first off, do I want to work with the left or the right-hand side? And the first thing I notice is everything is already in sine and cosine. So I can't use that very first strategy of changing everything to sine and cosine here. I'm going to choose the left-hand side. And the main reason is I don't know what I can do with the right-hand side. There's not a whole lot. Whereas on the left-hand side, it has parentheses that aren't on the right-hand side. So I'm going to start on the left getting rid of the parentheses. And if I want to get rid of the parentheses, I'm going to start by rewriting this. Sine x plus cosine x squared means sine x plus cosine x times itself. So I'm going to start there and then FOIL. So when I FOIL, sine x times sine x is sine squared x. Sine x times cosine is sine x cosine x. It's like xy. Cosine times sine x is cosine x sine x. And then cosine times cosine is cosine squared x. Okay, so now looking at that, I like a little bit about this. The first thing I notice is sine x cosine x and cosine x sine x. Are those the same thing? And I would say, yes, they are. And so I can put those together. And there are two of them. So I'm going to say 2 sine x cosine x plus cosine squared x. Looking at what we're trying to prove, we have part of what we want, right? 2 sine x, well, that's in, or 2 sine cosine, that's part of our solution. So the next thing is the sine squared and cosine squared is in there. So what I think of right away is sine squared and cosine squared, doesn't that equal 1? We have yet to use our identities. So can I rearrange this? I guess is my next question. Can I rearrange this as sine x plus cosine, or sine squared plus cosine squared, plus 2 sine x cosine x? Did I change anything by doing it? And I would say we did not. That is the commutative property of addition. And now I have sine squared plus cosine squared, which from my identity is 1. So I can replace sine squared plus cosine squared with the number 1. And now we have the same thing that we want. 1 plus 2 sine x cosine x.